Hello, and welcome to the BESS conference and to this presentation where we are going to discuss the assessment of the potential delivery of ecosystem services to support landscape planning, management, and decision-making. We will start by explaining the structure of this presentation that can be divided into 5 sections. First, we will introduce the relevant topics, namely the ecosystem service concept and their role in landscape planning and management, also presenting our main goals for this research. Afterwards, we will briefly talk you through our study area, the Alto Minho region, and outline our methodological approach. In the third section, we will highlight our core results, followed by a short discussion on the most relevant avenues for future work in the fourth section. And finally, we will present the major conclusions. Introduced in the 80s, the concept of ecosystem services has gained relevance in the field of environmental sciences by acknowledging the value of ecosystems to humans as natural capital. Ecosystem services is also a compelling concept to describe the intricate biophysical processes and their socio-economic linkages, allowing the integration of multiple value domains, therefore providing a suitable framework to guide sustainable resource management. Moreover, mapping ecosystem services is one of the topics within the ecosystem services research field that has gained much attention in recent years, especially because spatial data can be a very effective tool to communicate complex information accessible to the public and decision makers. And with regards to categorization and description of ecosystem services, the CIS initiative, the Common International Classification of Ecosystem Services, which was launched in 2009, aimed at helping standardize the ecosystem service categorization by proposing a classification based on 3 categories, as you can see on the left figure. Sorry. The 3 groups are provisioning services, which relates to the material benefits derived from ecosystems, such as production of food or timber. The second one is regulation services, which means the regulatory capacity of ecosystems, such as capacity to regulate the climate, maintain water quality, or protect against soil erosion. And finally, cultural services, which result from human-nature interactions, providing intellectual or physical enrichment. Now, in the field of landscape planning, ecosystem services are envisioned as a powerful tool to support management and decision-making. And since the early 2000s, there have been substantial efforts to transform the concept of ecosystem services into practice. However, despite continuous progress, the ecosystem service concept is still far from being firmly anchored in decision-making procedures and planning process. Therefore, to improve implementation, there is an urgent need for available and functional tools that can incorporate ecosystem services relevant to policymakers and managers. And we can do this either by making use of detailed local data and knowledge, by, for example, tailoring ecosystem services assessment frameworks to the local situation, also in collaboration with stakeholders, and by providing easy-to-use tools, which means that they pay attention to the required spatial data sets, also reducing time investment and learning requirements for the user. Now, concerning the main goals of this research, our aim was to first provide suitable, easy-to-use tools for mapping and assessing the potential for ecosystem service supply in our study area of Alto Minho, and secondly, to highlight the use of ecosystem services mapping and spatial tools and their relevance towards decision-making and landscape planning. Now, moving forward to the methods section, we'll first talk you through our study area. Our study area is called Alto Minho, and it matches the NUTSIII administrative region located in northwest Portugal, and it's bordered by Spain in the north and east, the Atlantic Ocean on the west, and the district of Braga on the south. So this region comprises a total of 10 municipalities, having its headquarters in Viana do Castelo, as you can see here on the coast. It occupies an area of approximately 2,218 square kilometers, with a population density of 250,000 inhabitants. Moreover, or more interestingly, the administrative region of Alto Minho extends at a gradually increasing altitude from the coast to the foothills in the east, composing an heterogeneous landscape of plain areas, large, narrow valleys, and mountain massives, featuring an outstanding social-ecological heritage. Okay, so now in relation to the land cover of the study area, you can see the corresponding map on the left and the occupancy rates on the right. Sorry. You can observe that most of the area is occupied by forests, approximately 40%, followed by approximately 26% of shrubland areas, and only 19% of the territory is occupied by agriculture. Now, about the natural value of the study area, we must emphasize that overall 30% of the Alto Minho region is within the European Union Natura 2000 network areas. And we have some examples of those in the images, as you can see on the left, matching special conservation areas, such as the Área do Corno do Bico on the upper right, or Lagoa de Bertianos and Serra d'Arga, as you can see below. However, we must emphasize or highlight the Peneda Gerês Park, as you can see in the upper left, which is the first protected area established in Portugal and the only one with a national park status. Now, as for the methodological approach, we implemented a three-step framework. We started by selecting the relevant ecosystem services for the study area based on its classification. Afterwards, we built the core metrics, ranking each ecosystem services founded on existing literature and expert knowledge. And finally, we mapped the potential for ecosystem service supply in a software, making the metrics spatially explicit. This way, it was possible to produce relevant tools to support landscape planning, management, and decision-making. So regarding the selection of ecosystem services, we target those relevant to the study area based on its classification and stakeholder point of view, which are listed in the figure 6. We selected a total of 6 provisioning services, 4 regulation, and 2 cultural services. Sorry. Concerning the matrix approach, it was first described by Buckert et al. An overall matrix approach links geospatial units, which they represent the service-providing units, and are generally land use classes, and they are linked with the potential for ecosystem service supply through an easy-to-apply lookup table. The potential of each land use class to provide each ecosystem services is established according to a qualitative scoring system that ranges from 0, indicating a minimum potential, to 5, indicating the highest potential supply of ecosystem services. In the end, the matrix allows for quick outputs, also in a spatially explicit manner through geosoftware implementation. And on the right, we can see the results of the Alto Minho ecosystem service matrix in the form of charts. And it's clear that provisioning services are of particular relevance in forests, agricultural areas, and pastures. As for the regulation services, forests and shrublands are highlighted. And finally, cultural services are relevant among several land use classes. Now, moving on to the results, among the 3 groups of ecosystem services, which are provisioning, regulation, and cultural services, our outcomes, they disclose a higher percentage of territory with an increased potential for delivering regulation and cultural services. With regards to the several provisioning ecosystem services assessed in the region, despite being less pronounced in the study area, it is possible to mark a significant share of the territory above 30%, with very high potential for timber production. Now, concerning regulation services, we pinpointed that pollination ecosystem services stands out in the study area, with above 50% of the Alto Minho displaying very high potential. Additionally, carbon sequestration was also found relevant in the territory, with approximately 40% of the region with very high potential. Now, as for cultural ecosystem services, both recreation and landscape aesthetic play a significant role at landscape level, matching an area above 50% with high and very high potential. But moreover, our outcomes disclose a high potential of the territory for delivering pollination and regulation services and cultural services, particularly within Natura 2000 sites. As you can see on the right, the relative area with high potential increases for these two ecosystem services inside Natura 2000. Now, it is important to briefly introduce the most relevant avenues for future work, and we present 3 pathways for improvement. And as for the metrics optimization, we advocate future complementation with biophysical data or intensity of land use. Moreover, further validation could be accomplished by incorporating quantitative indicators. Another path for improvement would be the assessment of synergies and trade-offs between bundles of ecosystem services, which could allow for impact analysis of different management options. Likewise, assessment of past and future trends of the potential for ecosystem service supply could also be a key tool for resource management and land use planning. These 3 paths could all be a good way to better appreciate the spatial and temporal heterogeneity of the landscape. Now, finally, we can conclude that this research, besides providing useful knowledge for the development of policies, strategies, and ecosystems management resources, has also provided suitable, easy-to-apply tools that can support landscape managers either to monitor the potential for ecosystem service supply in the region. Therefore, overall, our results, they highlight the use of ecosystem service mapping and spatial tools and their relevance towards decision-making, therefore contributing to more efficient and sustainable decisions on the use of limited resources and land use planning. Now, thank you very much for watching.